Welcome to this tutorial on the bucket command in Splunk SPL. The bucket command is a powerful tool that allows you to group your data into time buckets. This command creates time intervals and bins for temporal analysis and trending reports. Think of it as organizing your data into time-based containers, making it easier to analyze patterns and trends over specific time periods. This is particularly useful when you want to see how your data changes over time, or when you need to create visualizations that show temporal patterns. The basic syntax of the bucket command is straightforward. You use the pipe symbol followed by bucket, then specify the field parameter which should be set to your time field, and the span parameter which defines your time interval. The field parameter tells Splunk which time field to use for bucketing. Typically this would be _time. The span parameter determines how large each time bucket should be. This simple syntax creates time-based groupings that are essential for temporal analysis and trending reports. There are two key parameters you need to understand for the bucket command. The first is the field parameter, which specifies the time field to bucket. Most commonly, you'll use field =_time, which is Splunk's default timestamp field. The second crucial parameter is span, which defines the time interval size for your buckets. You can specify spans like span =1h for hourly buckets, span =5m for 5-minute intervals, or span =1d for daily buckets. These parameters work together to create meaningful time-based groupings of your data. Understanding the different time span options is crucial for effective bucketing. For minutes and hours, you can use spans like 5m for 5 minutes, 15m for 15 minutes, 1h for 1 hour, or 4h for 4 hours. For longer periods, you have days and weeks options such as 1d for daily buckets, 3d for 3-day intervals, 1w for weekly buckets, or 2w for biweekly periods. For even longer analysis, you can use monthly spans like 1 mon for monthly buckets, 3 mon for quarterly analysis, 6 mon for semi-annual periods, or 1y for yearly buckets. Choose your span based on the granularity you need for your analysis. Let's look at a practical example of the bucket command in action. We start with index =weblogs to search our weblog data. Then we pipe the results to the bucket command with _time and span =1h, which groups our events into 1-hour time buckets. Finally, we pipe to stats count by _time to count how many events occurred in each hour bucket. This query groups weblog events into 1-hour time buckets and counts the events per bucket, giving you an hourly breakdown of web traffic. This type of analysis is extremely useful for identifying traffic patterns and peak usage times. The bucket command also provides advanced options for more precise control over your time buckets. The start parameter allows you to specify the bucket start time, typically set to start =0 to align buckets with standard time boundaries. The end parameter sets the bucket end boundary, which can be useful when you want to limit the range of your buckets to a specific value like end =100. These advanced options give you fine-grained control over how your time buckets are created and aligned, which can be important for specific analytical requirements or when you need to align with business time periods. Here's a more advanced example showing how to create trending reports using the bucket command. We start with index =sales to get our sales data. Then we use bucket _time span =1d to create daily buckets. Next, we pipe to stat sum of revenue as daily revenue by _time to calculate the total revenue for each day. Finally, we sort by _time to ensure chronological order. This query creates a daily revenue trending report with time-based grouping, allowing you to see how your sales revenue changes day by day. This type of analysis is invaluable for business intelligence and identifying sales trends over time. When using the bucket command, there are important best practices to follow. For performance, always use appropriate span sizes to balance granularity with system performance. If you choose spans that are too small, you might create too many buckets and slow down your search. If spans are too large, you might lose important detail in your analysis. For visualization purposes, The bucket command works exceptionally well when combined with timechart and stats commands to create effective trending reports. These combinations allow you to create compelling visualizations that clearly show temporal patterns in your data. Remember to always consider your analytical goals when choosing span sizes and combining commands. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.